right, good afternoon, everybody. It is the fourth question for the week, the synchronous satellite question. What we're trying to do is put a satellite in orbit around this planet so that it has the same period of orbit as the planet. So if I hit show question here, there's a few things that I definitely need to write down. The first is going to be the mass of the satellite. So we'll call that little m. That's going to be 162 kilograms. Planet's mass is zero point 0.6 times the mass of the moon. So the mass of the moon down here is going to be 7.36 times 10 to the 22nd. So I'm going to take the planet's mass and label it as capital M, and I'm simply going to take zero point 0.6 times the mass that's at the bottom of the page here in moon, 7.36 E22. And so I get, let's see here, mass to be 4.416 times 10 to the 22nd kilograms. All right. And the radius of the moon, it's 2.8 times the radius of the moon. So let's go down to the moon here. And let's look up the radius of the moon. The radius of the moon is 1,737,400. All right. And let's see here. 2.8 times that gives me the radius of the planet. So that's going to be 48,64,720 meters. And it says the period of rotation is 11.31 hours, which, if I convert that 11.31 times 3,600, gives me a certain number of seconds, about 40,000 or so, 40,716 seconds. And they want me to determine the altitude of the satellite in kilometers. So the first thing I need to do is I need to set up this idea of our general equation for the geosynchronous satellite. So I know the general equation for the geosynchronous satellite says that 2 pi times, we'll call r plus h divided by t, has to equal gm over r plus h square rooted. Velocity is equal to velocity, right? And r plus h, keep in mind, this is kind of your idea of the planet, right? You are going to be orbiting at some height above the planet. So we're going to call that height right there h. And of course, you have the radius of the planet. We'll call that distance right there the radius of the planet, right? So r is the radius of the planet, h is the distance above the planet, r plus h would be the radius of orbit. Okay, and they're asking for h in this calculation. So what don't I know in this calculation? Do I know t? Sure. Do I know pi? Yeah. Do I know r? Yeah. Do I know g is a constant? Yep. I know m and I know r. So really, I just have to simplify this and convert it to and solve for h. So what we have is 2 pi times r plus h quantity. Well, you know what? Let's do this. I'm going to do kind of a generic equation here. So I get 4 times pi squared times r plus h quantity squared divided by t squared. If I square that side, I also get the square of this side. So basically, it's just that without the square root. And now I can solve for r plus h. So r plus h quantity cubed equals gm, move the t squared up to the top on this side, and divide that side by both sides by 4 pi squared. So I can solve for r plus h would be the cube root of gm t squared over 4 pi squared. So that means h is equal to all of that subtracted by r. So h equals the cube root of gm t squared over 4 pi squared, subtract r. I know everything in that equation. So let's go ahead and solve. Let's see here. I'm going to do this over on the other side. H has to equal, let's see here, 6.67 times 10 to the minus 11 times the mass, which is, let's see here, 4.416 times 10 to the 22nd times t, which is 40,716 seconds. That's going to be squared. Divide all that by 4 pi squared. And we're going to take the cube root of all of that. And from that, we're going to subtract r, which is 48,64720. All right. So let's use our calculator and plug all this in. And when I plug all of that in, I get h to be 117,716.7 meters, which would be 117.72 kilometers. So that's our first answer. They also, in this little calculation, want us to calculate the force of gravity at that point. Force of gravity is Gmm over r squared. So 6.67 times 10 to the minus 11 times the mass of the planet, which is, that's 4.416 times 10 to the 22nd, times little m, which is 162 kilograms. Divide that by the radius of orbit in this case. So that's going to be, let's see here. That would be, what is the radius of the orbit? Did we calculate that? I guess we did. That would be that number that I got before that. So I'd have to add this number to the radius of the planet. So 117,000 or so. Add that to 4864 and you get the radius. So I got 4982436. And that number is going to be squared. So if I take 6.67 e negative 11, all right, I get the force of gravity to be 19.2. So I have my two answers. Let's see if we're in fact correct. It's a lot of math on this one. Just a lot of calculations with scientific notation, which is really what takes the longest. So if we hit enter answers here, I'm going to type in Oster's, type in the altitude. It's going to be, let's see here, 117.72. They do want it in kilometers. And the force of gravity is 19.22. So we hit submit. Going to launch just like the last problem did. And it looks like we are pretty much right on. That's the satellite where we want it. And let's see here. What did we get wrong? Predicted altitude was 117. Actual geosynchronous altitude was 111. So obviously we did something wrong here. Predicted gravitational force was 19.22. It was actually supposed to be 19. So we did that right. What did we get wrong here? We were off by about 6 kilometers. Planet's radius is 487. So I got 486,472. They got 4872. So obviously there's a miscommunication there. The orbital radius I got was 4982. They got 4983. The orbital period I got right, and the 4.42 times 10 to the 22nd was the mass. So they rounded the mass to two significant figures, which I think may have had an effect on everything else. So my suggestion would be maybe to round your mass to 4.42 instead, just because that's what they did here. And of course, that can affect everything else beyond that. I also probably plugged in my number wrong when I plugged in to find my orbital radius. They got 4872, I got 4864. So obviously, we did something different there to get the planet's radius. Not sure how I could have screwed that up, but I did. But the method that I used is absolutely sound. So if you guys want to use this method, that's fine. If you want to use your own and kind of plug it in your own way algebraically along the way, that's totally fine too. But this is kind of the method that I want you to use. It's too bad I was just outside of range. If yours ends up like this and you are really, really close and you can show your work, feel free to take a screenshot and show me your work, and I'll be happy to accept it. I realize this is a little bit tricky with all the scientific notation if you're off by even a small amount. So hopefully that's helpful. Sorry, it was a little bit out of range, but it is the correct. It is essentially going to be the correct method. So hopefully that's helpful. Talk to you soon.